Hi, and welcome to this video about the fundamentals of C# programming. We're going to start by going to a site called Replit, which you can log into using Facebook or Google or GitHub. And I'm going to make a new, make a new C# repo. So this is the basics of a C# program. I'm actually going to take this line out because I'm going to recreate it from first principles. And even this line here. This is pretty much the minimum you can have in a C# program. The first word you've got here is class. So everything about C# is object-oriented, which is based on the idea of classes. So our class here is called main class. You get to name it whatever you like. You'll find it in most environments. The words that appear in blue are keywords, which are reserved for the language, the programming language. And the words in black are identifiers for the most part, which you get to choose. So we could rename that if you want, but I'm not going to. Now this bracket here, I'm going to put that in the next line because I prefer the brackets to be on lines on their own, just a convention that I prefer to follow. The curly bracket indicates that everything inside here, you can click this little minus sign to collapse it. That's all part of this class. So whenever you see curly brackets, it's a container for other things. So everything inside these brackets, see how I click one and the opposite one is highlighted? You can see what's inside those brackets all belongs to main class. Now, what's inside a class? It contains two things, variables, which I'll get to later, and functions. Now in C#, functions are called methods, and every C# program must have a method called main. So again, we do get to choose the names of our functions, but this is the one that you must have. If you don't put a main function in, you can't create an executable program. You can make a DLL that we run by other programs, but you can't make a program without main. Now we don't need the word public, I can take that out. If you don't put public in, it will be presumed to be private. Don't really need to know about that just yet though. It must be static. Static just means it always exists, you don't have to create it. And void tells us what the function returns, in this case nothing. We'll get back to that later as well. It also doesn't need any parameters, so I could take that out. Okay, we finally got to pretty much the minimum every C# program must have: a class with a main function inside it. And this is called the entry point. This is where the processing for the program begins. I can actually click run just now. And did you see that nothing much happened, but we didn't get an error message. Now if I was to try and simplify that any further and then try and run it, we would get an error message. Some of these error messages are kind of hard to follow. You do get used to it with time. But in this case, the error says class structure interface method must have a return type. There's no return type in here. Let's put void. It's going to return nothing. Every function must have void or integer or boolean, or it must have a return type of some kind. Click run now. And a different error. The program does not contain a static main suitable for an entry point. It's telling us that this main needs to be static. Okay, so that's why I left them in. And that's why they have to be there. But what sort of stuff can we put inside? Well, it's traditional to put, as our first program, a line of code that's just going to display something on the screen. So that in C# uses the writeLine function. So we have our own function called main, but we're going to make use of somebody else's code in a function which they made, and that's called writeLine. Now, just like we had parameters for our function, they have parameters for their function, so we need brackets too. And if we try and run that, it won't work. Another error message, semicolon expected. Every statement, or nearly every statement, must end with a terminator, and that's a semicolon symbol, which just lets the compiler know that that's the end of a statement to be executed. Click run, and we'll get a different error message. WriteLine does not exist. So we're trying to call up this method called WriteLine, which Actually, it does exist, but it doesn't exist in the current context. We can't see it from here. I think we should be able to access it if we say system.console.writeLine, if I'm not mistaken. Let me just check. Yeah, so we've got a blank line. So that's because the WriteLine function exists within another class, not our main class, but another class, and it's called console. So the console class contains a WriteLine function. That console class exists within the system namespace, which is just a collection of things in a space. It's just literally what it sounds like. So look in here for this class and run this function on it, and it's going to display an empty line. And usually, the first thing we do when learning a programming language is say hello world, but instead I'm going to make it more video game oriented. It's going to say ready player one. So that's what we want it to write, but it's not going to like that either. It looks at the word or symbol, it calls it player, and says unexpected symbol, because the symbols that will make it work is actually to turn this whole thing into a quote, put quotation marks around it. That makes it something called a string of text, one character after another. So this string of text, it turns red when it's identified it as a string inside quotes. And that string of text is something that the console can write to the output. And there we go. So we're using the system and it's in namespace. We're using the console and it's in the namespace system. That's one of those lines I took out earlier. If we say this using system, then it gives us access. It lets us see everything inside there. Puts it in scope. That's its technical term. So now the console is within scope. We don't need to put the word system in front. May not sound like a big deal, but if you've got a lot of output, then it saves a lot of time eventually. Okay, so what we've got here is what's called a string literal. It's data that's put straight in to your code. It doesn't change, but it's not stored anywhere either, so it's not considered a constant. It's a literal, slightly different thing. Let's put in a few more. We'll ask the player what his name is. And we'll say welcome to him. How we manage to say welcome to the player though? Well, we need to combine this string here, which says welcome, with the string that contains the person's name. And that can be done using a plus symbol. That plus symbol runs an operation called concatenation, which merges two strings together. So if we put welcome Dave, that would just merge those two strings. There wouldn't be much point in doing that though, because we could just put it in one string. But what we want is for anyone to be able to run this, and so we'll ask them what their name is and let them type it in. Just so happens that the console has another command called readline, and because we're not putting anything out onto the screen, we don't need anything in its parameters, but we do still need the round brackets for it. So console.readline with no parameters. Notice how there's two brackets at the end there. We need to close the brackets for readline and close the brackets for writeline. You always need to close every bracket somewhere, and where you put that matters quite a lot. One of the most common errors is putting brackets in the wrong place. Anyway, let's run that. We should see 3 lines of text, but we don't. It's waiting for us to actually type in the read line. Why is that? Well, let me put it in first of all. Type in Dave, press enter, and it says welcome Dave. Why did it do it in that order? Well, when you pass in a parameter, it's kind of like BODMAS when you're doing maths, brackets, orders, division, multiplication, etc. It's got a certain order of things, and if things are inside brackets, they get done first. So it does this concatenation operation first. But it can't concatenate it yet because it doesn't know the outcome of this read line. So it has to run the read line first, then it concatenates. That's called evaluating that expression. And then it writes the output of that to the screen. Okay, now we're starting to get somewhere. But what if you wanted to remember that name for later on? Well, you need to store it somewhere, and that's where we get variables coming in. Excuse me. So we want to, let's say, I'm going to cut that. Let's say we want to write the person's name. We want a variable called name. And if I try and run that, it shouldn't work, of course, because name doesn't exist. So we need to make something called name. We need to tell the computer to set aside a little bit of memory to store the person's name. And that is going to be a string of text. So we can use a keyword string and then say that this string is going to be called name. So what we're doing there is saying, put aside a bit of space to store a string, call that space in memory name. That's called declaration. We're declaring a variable there. And this, by the way, bit in grey, that's called a comment. 2 forward slashes puts in a comment. A comment is not code, it doesn't run, it's there just to explain things. Anyway, so we've got a string called name. If we try and run it, guess what? We get an error message. Use of unassigned local variable name. We're trying to use the word name, or the variable name, but there's nothing in it because we haven't assigned it any value. You can assign a value to something by using the assignment operator, which is the equals sign. So if we say string name equals Dave, we put a literal string into that variable. If you run it now, welcome Dave. Okay, no prizes for guessing what comes next. I'm going to paste in that read line. So we declare a variable and we also assign it a value in one go. This is called initialization. So you initialize the value. In this case, we're actually initializing it with an input from the console. You should do things in still the same order. Type in Dave. It says welcome Dave. But we can use that name again. I'm going to do a double concatenation here. Stick a question mark on the end. Okay, so now we've stored that string variable for use later on. As you remember, I mentioned scope briefly. So there's things inside the scope of this namespace. The console is inside it. This name variable, because it's declared inside these curly brackets here for the code that's inside the main function, that variable only exists inside these brackets. That's called local scope. So it can't be used anywhere else except inside the brackets where it's declared. Variables can also be made member variables in C#. You could do it here. We could declare a string called name. We wouldn't need to declare it a second time then, but we would still need to use the variable. We could make that a member variable now instead of a local one. And unfortunately, that's going to be a bit iffy because it's going to say, well, some error messages here. An object reference is required to access non-static member name. We've got a static function that exists always, trying to access a string that isn't static. It doesn't always exist, and that's a problem. So let's make it static. Back to working. So now this is no longer inside the curly brackets for the main function. It's inside the curly brackets for the main class. It's a member variable, member scope. By the way, see I put a blank line in there. It's very common to have a blank line separating things inside your class. Almost every developer house does that. Yes, so this is a member variable. We can use it inside the main function. You can use it inside any other functions you might put down here. Not always necessary, not always useful, in fact, but you should be aware of the difference. Some languages have something called global variables, which I guess would be put out here if you could do it in C#, but you can't do it in C#, it's just not allowed. Other languages do let you do it. Okay, so that's the very basics of variables. There's only one type I've shown you so far, which is strings. But there's plenty of others. You can have an integer. So there's my age. And you can plug that into a concatenation as well. It will automatically convert that into, from an integer. By the way, an integer, in case you're not sure, it means a whole number. And in fact, there are 32-bit integers. You can put in the .NET version, which is int32 if you wish. Actually, I'm not sure if that will work in this particular environment. It does, okay. So you can put int32, which is the class version, or int, which is the keyword version. But either way, it's a whole number, and you can concatenate it into a string. But what it does there is it converts it automatically for you from a number into a string. Other types you can get, well, an integer is 32 bits, as I just said. You can make a long integer. I'm not old enough to use numbers more than 4 billion my age, but not far off. But that's the limit. 4 billion is about the limit for integers. If you need to byte a number longer than that, you need a long integer. That's a 64-bit number. You can also get short integers, which is 16 bits. And their maximum number is 65,000-ish, if I remember rightly. You can also have a byte, which is 8-bit numbers. There's plenty of other ones as well. Character for a single letter. Single letter characters use apostrophes around them rather than quotes. And booleans, which is a value which can either be false or true. That's its only possible options. There's some other ones that we'll see going forward. But the next thing to look at, and probably where I'll leave it with this video, is operators, because so far we've seen the assignment operator, the equals sign, the concatenation operator, the plus sign, but you're probably thinking, well, that's not usually what plus does. So let's make an integer and call it age. I was 43, but then we can say age equals age plus 1. So if we take the age, which is 43, and add on 1, we get 44. We then assign the value of that evaluated expression back to the age variable, so it becomes 44. Yep, there we are, 44. But there's different ways to do that. We can shorten that. If we want to add 1 on, or add, let's say, 3 on, then you can shorten that by doing this shortcut, plus equals 3. That means the exact same thing. It's just a shortcut for it. It's what we call semantic sugar. It does nothing new, but lets you do something that you could have done another way, more simply. If you want to just add on 1, there's another even shorter way to do that, which is age plus plus. That's where C++ got its name, by the way. The original language C, they made the next one C++. Aren't programmers hilarious? You can also do age equals age minus 1 if I'm somehow going backwards in age. And as you can imagine, that's equivalent to saying age minus equals 1. Or minus minus. You can't do minus 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 minus. That doesn't subtract 2. It's not smart enough for that. If you want to subtract 2, you have to do minus equals 2. Those are called compound operators. You can also multiply by 2, which is the asterisk, or divide by 2, or even do a modulo by 2, which I'm not going to talk about much just now, but they're all there, and you can apply them as a compound operator or in long form, like if you want to triple your age equals age times 3. That's the very basics then. Commands are operated one line after another in sequence. Variables are just a place in memory which need to be declared before use. There are functions which are stored within classes, and the one called main is where your entry point is to start processing. Operators include things like the equals sign, the asterisk for multiplication, the plus sign, etc. And what they do is context dependent, because a plus sign for strings means concatenation, a plus sign for integers rather, means literally adding. And there's a lot more to go on from after that, but I think that will do for now.